Good evening, students. Today's topic is grade 11 chemistry redox reaction. Before we enter into the topic, we need to know what do you mean by oxidation state or oxidation number. See, we know how many types of reactions and all those things, but a special type of reaction which we need to focus is redox reaction. In this, we can see two terms. What is the first term here? Reduction. And what is the second term here? Oxidation. So we can define a redox reaction like this. Any reaction in which both reduction and oxidation takes place simultaneously, that reaction is called redox reaction. Now, to know what is reduction and what is oxidation, we have to identify what is oxidation state. Now let us go in depth. What do you mean by an oxidation state and oxidation number? So let us have some rules. There are totally 6 rules. To find out the oxidation state, we have 6 rules. Let me write rule number 1. According to rule number 1, all elements will have oxidation state as 0. Now onwards, oxidation state I will represent as O dot S. What does the statement say? The statement says all the elements will have oxidation state is 0. Now let us see what are those elements. Any examples like H2 and halogen Cl2, Br2, I2. If you take metals, sodium metal, magnesium, aluminium, and you want to go with triatomic, that is ozone. Next, P4, S8, all these are elements. And if I want to write the oxidation state, what I'll do, I'll circle this. Above this I'll put 0. That means the oxidation state of hydrogen element is 0. If you want to represent chlorine oxidation state, circle that and keep 0 upon that. Hope you have understood this. So what is the first rule? The first rule says that for all the elements, that means it is not combining with the other atoms. It is made up of same type of atoms. That is why you call it as an element. Fine. So first rule is done. Now second rule. The second rule is for a single atom, okay, a single atom with either it can have a positive or a negative ion. So I'll simplify this. Let me simplify the second rule. So we know what are alkali metals. Alkali metals are group 1, and you know the shortcut method also. Helena kiya rab se Faryad. Based on that, I will write hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Don't take hydrogen because you know we are studying hydrogen separately as of now. And don't take francium because it is radioactive element. Now, if I want to have the oxidation state, so what I will do? Either I have to add electron or remove electron. Let us take lithium. Atomic number is 3. So we can take 2, 1. So we don't want to go into 1:2 2:2 configuration. To explain in a simple way, I wrote 2, 1. Then sodium 281. Next potassium 2881, so and so on. What we understand here? We understand that the valence electrons are 1. In the case of alkali metals, that is group 1 elements, the valence electrons are 1. So what you need to do to get stability, that is either duplet configuration or octet configuration. What we need to do? So duplet is nothing but double, that is 2 electrons in the outermost shell. Octet, oct means 8, therefore 8 electrons in the outermost shell. Any one you should do. So let us try this. For lithium, what I can do, I have to add 7 electrons, then it will become 8, is it right? 1 plus 7 will become 8, that means octet. Or one more thing you can do. What you can do? Simply remove this. Remove 1 electron. If you remove this, now I got 2, nothing but duplet, so it becomes stable. Hope you are able to understand this. So which is easy here? Removing 1 electron is easy. Now what will happen after removing? Let me write. At the center you have 3 protons, is it correct? And here n is equal to 1 and n is equal to 2. You have generally 2 and 1. But now what we did? We removed 1 electron. So therefore what will happen? You are having 3 positive charge and you are having only 2 negative charge. Hence what will happen? You will get plus 1. So now shall I write for Li plus 1? Yes. So now the charge on atom lithium is plus 1 because you removed 1 electron to get a duplet configuration. Same thing. Sodium, again the same. Either you have to add 7 or you remove 1. Removing is easy. So after removing, what will happen? In the case of sodium, with atomic number 11, I have 11 positive charge, that is protons, and after removing I will have 10 electrons, that is minus, and once again you have plus 1. So applying that, what I can write? Sodium plus 1. So keeping this, I will get a similar thing. That means all the alkali metals, after losing 1 electron, gets which charge? Plus 1 charge. And that charge what they get is nothing but its oxidation state or oxidation number. So hope with the example you have understood what is meant by oxidation state and about alkali metals having plus 1 oxidation state. Now one more group we will take, that is second group, alkaline earth metals. Alkaline earth metals, that is second group, alkaline earth metals. Alkaline earth metals. You know the shortcut for this, no? Beta manga car scooter bap razi. With that you will get beryllium, magnesium, calcium, strontium, barium, radium. Radium is radioactive, hence don't consider this. Now with atomic number 4, 2, next with 12 it can be written as 282, next becomes 2882 and so on. So what you will see here? We will see that the valence electrons are 2 here. Now again, what are the 2 states of stability? Number 1 duplet and number 2 octet. So how to get, if at all you have 2 electrons, how you can get stability? First, I can remove this. Remove 2 electrons, or what I can do, I can add 6 electrons. See, 2 electrons are there, add 6, then total will become 8. That means you will get the octet configuration. In these two, which is easy for us, here a removal of 2 electrons is easy. So let us don't go for the other option. So all the cases, what I'll do, I will remove 2 electrons. So let us see what will happen if you remove 2 electrons. Beryllium +4 charge after removing now has -2. So it is left with +2 oxidation state. So if I want to write here finally, after the removal of 2 electrons in beryllium, I can take +2 oxidation state. Similarly, in this case also you removed 2 electrons. So how many we have totally? 10 minus. But due to the atomic number 12, magnesium has 12 protons. After removing 10 electrons we got, so 12 minus 10 will be 2, and here it will be +2. So again magnesium also +2. Similarly, by the removal of all this, now we got stable configuration. Beryllium gets a duplet configuration. Next, magnesium gets octet configuration, calcium gets octet. Similarly, all these will get stable octet configuration. Hope you are following this. Hence what I can write? I can write like this, that is calcium +2, strontium +2, barium +2. Finally, oxidation state of alkaline earth metals can be +2. Hope you are able to understand. So alkali metals oxidation state is equal to +1. Okay, we got an information from alkali metals and an information from alkaline earth metals. But what is the rule? What is the rule? The rule number 2 says, if you have a single atom, in other way I can call it as a single ion. It's a single ion, cation, even you can have anion also, negative charge. So a single ion, if at all you have a single ion, then the total oxidation state is equal to charge on the ion. Simple statement, what is that? If you have a single ion, the total oxidation state is equal to charge on the ion. Let me take an example and tell alkali metals, all alkali metals you take. I am having Li +1. Therefore, I have to write what is the total charge on this? +1. Sodium with +1 charge. What is the total charge on this? That is, total oxidation state is +1 is equal to the charge on the ion. What is the charge on the ion? +1. What is the total oxidation state? +1, because you have a single ion. Now you can take other examples from here. Calcium, let us take 2 + R + 2. Now the single ion is there. What is the charge on that single ion? 2+. Therefore total oxidation state, again I can write it as +2. So same what you have, and here also you will have the same thing. So the rule says, if you have a single ion, then the total oxidation state is equal to the same charge which is present on that single ion. Hope you have understood this. Please keep in mind alkali metals and alkaline earth metals. Now, rule number 3, it is for oxygen. See, generally in lower classes and all, you will see like this, CaO you will write. Then what do you call it? You call it as calcium oxide. Okay. So here you are not knowing what is oxide or what is peroxide, etc. So now let us see with the rule number 3, which gives the oxidation state in an oxygen, and what are the exceptions in that. Now I'll take a simple example here with the same group 1. I'll write like this: Li2O, Na2O2, KO2, RbO2, potassium, rubidium, cesium, CSO2. Okay, I have written this. Next, we have to know the oxidation state of oxygen. So underline that and take it as X, and you know the total will be 0. Here also underline this, keep it as X, and the total is 0. Same thing, underline oxygen and total will be 0. RbO2, underline oxygen you have to find, therefore keep it as X, here also X, total is 0. CSO2, this is X, and then total is 0. See, very simple. What I am doing is I have to find out oxidation state of oxygen, so I have taken it as X, keep it as X in all these examples. Then you know, or generally the sum of total charge is 0, so I have kept it 0 on the top. This is total oxidation state. Now lithium, sodium, potassium, rubidium, cesium, you know that oxidation state is +1. So lithium, sodium, potassium, rubidium, cesium is +1 alkali metals. Therefore what I'll do, I'll write +1, +1, +1, +1 and +1 to this. Okay, now let us calculate this first equation. What is the equation? See, +1 into 2, that is +2. See, 1 into 2 is 2. Next, plus, here we have one oxygen index, so X is equal to 0. Therefore, what I can do is, I want to know X, therefore send 2 to the other side. X is equal to, now it is +2. If it moves to other side of the symbol, it will become -2. So in this condition, what is oxidation state? That is nothing but -2. Whenever oxygen is having the oxidation state as -2, you call it as oxide. So I am writing a simple word, that is oxide. What is an oxide? Whenever you have -2 oxidation state for oxygen, you call it as a oxide. Okay. Second, so all this 2 into 1 is 2. 2 into X is 2X is equal to generally 0. Now +2 sent to other side, so 2X is equal to +2 is there, on the other side becomes -2, so X is equal to 2 into X now becomes divided by 2, that is equal to -1. Hope you are able to understand. Earlier it was -2, but now it is -1. Whenever oxygen has oxidation state of -1, you call it as peroxide. Therefore, I'll write the name here. This is called as lithium oxide. This one is called sodium peroxide. Hope you are able to understand the difference here. Always O is not called oxide. O is called oxide only when you have -2 oxidation state. Example, this one, or just now you took CaO. Here also you can say calcium is +2, this is X, total is 0. Now how to calculate, you know this, no? +2 plus X is equal to 0. Send this to other side, so X is equal to -2. Whenever -2 we have, you call it oxide. Therefore, calcium oxide. Hope you understood this. Fine. Come to the next 3 conditions. That is KO2. I have KO2. Again, you know, X, potassium +1, total is 0. Equate this, what you will get? So 1 plus 2 into X, 2X is equal to 0. Send 1 to other side. 2X is equal to, this is +1, now becomes -1. X is equal to into 2, right? It will become divided by 2. Now X is having oxidation state of -2 in this case and in this case. So that is called as superoxide. So I am explaining you about the 3 important oxidation states of oxygen. First one is oxide, second one is peroxide, third one is superoxide. What is the difference? -2 is oxide, -1 is peroxide, -1/2 is superoxide. So what I can say, one example we can take, that is, you can call it as potassium superoxide. So hope you have understood the 3 types. Now next, what are the other oxidation states? Let me write OF2 and then O2F2. See, what is OF2? Oxygen 1, 2 fluorine. So I will write oxygen difluoride. The other side, 2 oxygens are there. Therefore, dioxygen, here dioxygen, again 2 fluorines will be difluoride. Hope you are following this. Now we want to know the oxidation state again. Take it as X. Here also underlined one is X. And F you know very well, it is -1. How F is -1? Atomic number is 9. Configuration becomes 2, 7. To get octet configuration, what we do? We add 1 electron, right? So at the center 9 plus, but outside 2, and after adding single electron it becomes 2, 8. Now count the protons and electrons. +9, but here 10 are there, -10. So finally you will end up in -1. So fluorine always will have -1 oxidation state. Total is 0. Now let us calculate. This is X, and -1 into 2, -2, total 0. Hope you are able to understand this. Next, because it is -2, if you send it to the other side of equality symbol, it will become +2. So hope you are able to understand. Till now, what are the oxidation state we saw? First one is -2, second one -1, then -1/2. Now you are also seeing positive oxidation state for oxygen, that is +2 in the case of oxygen difluoride. Next, what about this one? So taking it as X, 2 into X becomes 2X. 2 into -1 becomes -2. Total is 0. Fine. Now send -2 to other side. It will become +2. Now X is equal to 2 into, now becomes divided by. That is equal to +1. So hope you have understood this. In the case of dioxygen difluoride, the value or the oxidation state of oxygen is positive, that is +1, and in the case of oxygen difluoride, the oxidation state is +2. In both the conditions, oxidation state is positive. These two are exceptions. So rule 3 about oxygen we have completed. Now rule 4. Let us see hydrogen. What are the possibilities in hydrogen? Rule 4. Hydrogen. See, before you were having element H2 is 0. So in the element, you know that oxidation state is 0. But 2 more things are there. Example, HCl, NaH. We have so many examples, but what I want to show you is one example. Here sodium is a metal plus hydrogen, and here a chlorine is there which is non-metal. So that means what I am doing here, In the first case, I am combining hydrogen with non-metal, and in the second case, I am combining hydrogen with a metal. So let us see what will be the oxidation state. Now, take hydrogen is X and chlorine, you very well know, atomic number 17, configuration 2, 8, 7. If the valence electrons are 7, what will happen? Either add 1 or you have to completely remove 7, which is easy. Adding just 1 electron is easy compared to removing 7 electrons. So this is not followed. Add 1. If you add, what will happen? 2, 8, 8 you will get. Fine. What will be the charge in our oxidation state of this? At the center 17 protons are there, but after adding 1 electron you have 2, 8 and 8. Count this. How many electrons are there? 18 electrons are there. So let us write now. Plus 17 minus 18, how much? Minus 1. So chlorine has now minus 1 oxidation state. So let us write minus 1. The total is 0. So hope you have understood this. So what is the oxidation state now? So you know this is X and minus 1 is equal to 0. So X is equal to plus 1. That means whenever hydrogen is combining with a non-metal, the oxidation state will be plus 1. Second condition, Na is plus 1 we know, and H you take it as 0, and algebraic sum of the total charges will be 0. So now let us write equation, that is 1 plus X is equal to 0. So now send this 1 to other side. X will become minus 1. Hope you are able to understand the difference. What is the difference? If hydrogen combines with non-metal, it is plus 1. If hydrogen combines with metal, it is minus 1 oxidation state. So any place where minus 1 oxidation state is observed, and that is called hydride. Hence you call it as sodium hydride. If H has minus 1 oxidation state, you call it as hydride. So many examples are there. That is sodium borohydride, lithium aluminum hydride, etc. In all the cases, you have minus 1 oxidation state. Sodium borohydride. Fine. Take it as X. Sodium plus 1. So boron atomic number is 5. Configuration 2, 3. Remove 3. So B will get plus 3 oxidation state. Total 0. Now equate this, what you will get? 1 plus here 3, 4 into x, 4x is equal to 0. So I can write like this, 4 plus 4x is equal to 0. 4x is equal to 4 on coming to the other side, minus 4. X is equal to minus 4 by 4. Cancel it and x will get minus 1. If hydrogen gets minus 1 oxidation state, you call that as hydride. Therefore, I will write like this, sodium. This is boron, so boro. H is having minus 1. I will write it as hydride. So hope you have understood this. So what I can write? Hydrogen can have 0 oxidation state, and it can also have plus 1 oxidation state. It can also have minus 1 oxidation state, depending upon whether it is metal or non-metal. So here it is element. Next, this is non-metal with the non-metal, and the last one, it is with metal. So hope you have understood the rule number 4, how to calculate the oxidation state of hydrogen. Next, rule 5, halogens. Rule 5 is halogens. You know what are halogens? Salt, forming elements. Halogens are salt forming elements. Example, you know, right? NaCl. So chlorine when combines with sodium will give us salt. Hence you call this chlorium as salt forming element, nothing but a halogen, that is 17th group elements. So all 17th group elements, fluorine, fluoride, chloride, next bromide and iodine. See, the difference is very simple. If you are writing just F, it is fluorine, and take gas F2. Next Cl2, chlorine, INE, gas. Next Br2, it's a liquid, BROMINE, bromine. So all these have oxidation state 0. Same way I2, a solid, sublimate, iodine, once again INE. But if you have -1 oxidation state, then fluoride, IDE. So here it is INE, here it is IDE. That means, you know, F9 2,7, add 1 electron. I explained this earlier also, so I am going faster here. Adding 1 electron, what will happen? 2,8 plus 9 minus 10 will become -1. So all this will have -1 oxidation state. So this is chloride, this is bromide, and this is iodine. Fine. So 0 oxidation state and always in the -1 oxidation state. Now one more oxidation state is there where you have halogens as positive oxidation state. So what are those? Hypohalous acids represented as HOX. Very important thing. What are hypohalous acids? So HOX, general formula. So in this condition you should know the oxidation state of X, where X is equal to fluorine, chlorine, bromine or iodine. But avoid fluorine, highly reactive, and you can take the rest of the halogens. Substitute that HOCl, hypochlorous acid. See, in the place of halous, because chlorine you took, you are writing chlorous. Hypohalous acid, HOX, X is equal to chlorine, becomes hypochlorous. If you put bromine, hypobromous, taking it as X, and you know O is -2 and H is +1, the total is 0, equate +1 -2 plus X is 0. Now these two, -2 and +1 is -1. Send this to other side, X will become +1. So hope you have understood this. Generally element state, 0 oxidation state and -1 oxidation state also we have seen, but halogens can also show positive oxidation state, that is +1 in the case of hypohalous acids. So example I have shown HOCl. So hope you have understood the rule number 5, that is for halogens. Next, rule number 6, that already we are following, but still I'll write it separately. Rule number 6, it says that the total oxidation state is equal to sum of the oxidation state of individual ions. So very simple. Total oxidation state is nothing but sum of the oxidation states of, inside that you have so many ions. Example, H2SO4, H2SO3. Once again I want to give important difference because you call it as sulfuric acid, IC, and this will be known as sulfurous acid, OUS. What is the difference between ic acid and us acid? So when you have high oxidation state and in some case you have low oxidation state, that is same atom can show both high oxidation state as well as low oxidation state. See, high oxidation state, less alphabets, low oxidation state, more alphabets. So I hope you are able to follow opposite way. Now high oxidation state you are taking, you want to use less alphabets. Between what? Between ic and us, where you have less alphabets in the ic, hence what you will do? You will use the ic. That means high oxidation state, ic. Next, low oxidation state, more alphabets na 1, 2, 3. Therefore you will write us. Hope you are able to understand here. High oxidation state ic, low oxidation state us. Keeping that in mind, let us calculate X for sulfur. Here also X for sulfur. Accordingly, it says total oxidation state is equal to sum of the respective ions. So I will take like this. If you add all the charges, that is hydrogen plus 1 and sulfur X, oxygen minus 2 into 4. If you add everything, the total will be equal to 0. Right? Hope you are able to understand this. So definitely it will be equal to 0 only. Let us see, 2 into plus 1 is 2 plus X and 4 into minus 2 minus 8 is equal to 0. So X minus 6 is 0. Send minus 6 to other side, it will become plus 6. So in H2SO4, oxidation state of sulfur is equal to plus 6. Similarly, in H2SO3, let us calculate. So what is that? This is plus 1 minus 2 and total is 0. So what will get? This you have understood, so I am removing this. 2 plus X minus 2 into 3 minus 6 is equal to 0. 2 minus 6 minus 4 and you send it to other side, becomes plus 4. Now very simple. High oxidation state, less alphabet means ic. Less oxidation state, more alphabets means us. That is why you wrote sulfurous acid and here you wrote sulfuric acid. So hope you have understood all the rules now. Next. So using this, we need to solve one exercise which is given in your textbook. That is, first question they are saying underlined, that is NaH2PO4, in that P is underlined. Second one is NaHSO4. Next, third one K2MnO4. See, I will solve these three, remaining you can please do it as your practice. Now here we have sulfur underlined and here it is Mn. Now what is the first rule? The first rule says that the oxidation state of which element you have to find, keep it as X. So I will keep it as X. Next, with the rules, you know, sodium plus 1, hydrogen plus 1 and O minus 2. And the algebraic sum will be equal to 0. Let me write the equation. Plus 1, 2 into plus 1 plus 2, this is X. 4 into minus 2 minus 8 and total is 0. So 3 minus 8. So x minus 5 is 0. X is equal to, send it to other side, it will become x is equal to plus 5. So hope you have understood. So phosphorus oxidation state here is plus 5. Now second one, sodium plus 1, H plus 1, oxygen minus 2, total 0. Write the equation, plus 1, and sulfur is x, minus 2 into 4, minus 8, total 0. So here 2, so x minus 6 is 0, send minus 6 to other side, x will become plus 6. So sulfur oxidation state plus 6. Next, K2MnO4. Now let us take potassium is plus 1, x for Mn, O minus 2, total 0. Equate this 2 into plus 1 is 2, plus x minus 2 into 4 is minus 8 is equal to 0. You know 2 minus 8 minus 6. Send minus 6 to other side. So x now will become plus 6. Therefore oxidation state of Mn is plus 6. So I have done 3 questions for you. So the remaining questions in the textbook you can please solve. And if you have any doubts, please send it to the mail ID which is given in the description box. Okay. So hope you have understood. Thank you so much.